What if I told you that the Las Vegas qualifying disaster that pushed Lewis Hamilton to the 20th position was not only the worst Saturday of his career, but a moment that sent shockwaves through Ferrari, triggering visible frustration not just from Hamilton, but also from Charles Leclerc, both furious with the same hidden problem inside the SF25. You saw Hamilton finish last, but you did not see the deeper catastrophe. The Ferrari simply could not heat its tires. The icy street surface kept the Pirelli intermediates far below their operating window, and Hamilton was left driving a car that skated like it was running on glass. Even Leclerc, who reached the 9th position, complained that the tires refused to fire up and that Ferrari had once again fallen into the same technical trap. This was not just about poor grip. Hamilton struck a track cone hidden in the spray, possibly damaging the underfloor, and then suffered another radio communication failure with Riccardo Adami. Meanwhile, Leclerc expressed frustration at the car's lack of flexibility and how Ferrari could not adapt the SF25 to the freezing conditions. The anger inside the garage was real and shared by both drivers. Stay right here, because once you understand why both Hamilton and Leclerc were furious with Ferrari, how the tire heating problem destroyed the entire qualifying session, and how a cone, the cold, and communication disaster combined into a perfect storm, you will see the inside story that no one has shown you until now. The Las Vegas qualifying session became one of the most punishing Saturday nights Ferrari had faced in recent years. Heavy rain, freezing asphalt, and street surface unable to retain temperature created the worst possible environment for the SF25. Lewis Hamilton knew immediately that the night would not follow a normal pattern. His out lap revealed tires that refused to warm, a front axle that drifted without warning, and a rear that snapped unpredictably. The car felt disconnected from the track, as if the rubber were sliding over polished stone rather than gripping a racing surface. From the first corner, the car sounded the alarm. As Hamilton completed his first flying lap, the problem deepened. The intermediate tires, already cold, began losing even more heat through the long straights. By the time he reached the next braking zone, the rubber had fallen below the minimum temperature required to provide stability. Ferrari's telemetry confirmed this collapse in real time, watching tire temperatures drop sector after sector. Hamilton felt the front tires wash wide, forcing him to use steering corrections that further reduced heat. Every attempt to push simply made the situation worse. The car was not unstable by choice. It was unstable because physics had stripped away its ability to function. Charles Leclerc was suffering the same problem. Even though he would ultimately qualify far ahead of Hamilton, his radio messages reflected deep frustration. He reported that the tires were not switching on, that the grip was inconsistent, and that the SF25 could not adapt to the rapid temperature changes. For both drivers, the issue was not driving style or setup. It was structural. The Ferrari simply could not generate the tire energy needed to activate the car's aerodynamic platform. In a session like this, where grip depended entirely on keeping the tires alive, Ferrari had no tools to stop the downward spiral. The turning point for Hamilton came during a preparation lap, hidden under intense spray. Visibility was so limited that he could not identify the obstacles on the track. In that moment, he struck a displaced cone that had been left on the racing line. The contact looked small from the outside, but for a ground effect car, the underfloor is the most sensitive aerodynamic structure. Even minor interference can distort airflow, reduce downforce, and make the car unpredictable. Hamilton continued the lap unaware that this impact may have compromised the only aerodynamic stability the SF25 still possessed. This became one of the critical findings in Ferrari's post-session investigation. When Hamilton attempted what should have been his decisive push lap, he faced the same cold tires, but now with the car potentially destabilized beneath him. The front refused to rotate cleanly, the rear stepped out with delayed reaction, and the SF25 felt even more unpredictable than before. To make matters worse, a radio miscommunication with Riccardo Adami created confusion at the exact moment Hamilton needed clarity. He believed the session had ended after seeing red lights through the spray, while the team tried urgently to tell him he still had time. That hesitation cost him his final chance, sealing his position at the very bottom of the grid. Leclerc, watching the chaos unfold from a different part of the circuit, was equally frustrated despite securing a far stronger result. His feedback echoed Hamilton's complaints. The tires would not heat. The balance changed every lap. The SF25 was at the mercy of the cold surface. For Ferrari, this session exposed a flaw that both drivers had warned about earlier in the season. When the car cannot warm its tires, its entire aerodynamic concept collapses. This was not just Hamilton's nightmare. It was a structural failure that left both Ferrari drivers furious, confused, and demanding answers long after the checkered flag fell. The core problem that detonated the frustration of both Lewis Hamilton and Charles Leclerc in Las Vegas qualifying was the complete inability of the Ferrari SF25 to generate tire temperature. On a night defined by cold rain and a surface that behaved more like polished concrete than a racing circuit, the tires refused to fire up. Hamilton felt this immediately. In the opening minutes, he turned into the first corners only to find that the front tires drifted across the surface with almost no grip. The rear axle then responded with sudden instability, leaving him fighting a car that provided no foundation whatsoever. The SF25 was not misbehaving by accident. It was failing at the most basic level of performance. As Hamilton attempted to push harder, the situation worsened. The long straights of Las Vegas drained what low heat the tires had accumulated, and by the time he reached the braking zones, the rubber had already cooled below its operating threshold. Ferrari's internal telemetry confirmed this behavior, showing tire temperatures dropping steadily from sector to sector. Hamilton had no way to build momentum. Each slide removed more heat, and each correction made the next corner even less stable. What unfolded was a cycle of thermal collapse that Hamilton could not control from the cockpit, no matter how carefully he managed the grip he did not have. Leclerc experienced the exact same phenomenon, though his lap placed him higher on the grid. His radio messages revealed deep irritation at the car's inability to activate the tires. He explained that the grip never arrived, that the balance shifted unpredictably, and that Ferrari had no answer for the cold track. This was not an isolated problem affecting only Hamilton. It was a structural weakness in the SF25. Both drivers found themselves stuck in a car that simply could not switch on its tires, a flaw that becomes catastrophic when the entire qualifying performance depends on thermal stability. For Hamilton, the situation became even more complicated when he struck a cone hidden within the spray during a preparation lap. The impact appeared harmless, but for a ground effect car like the SF25, the underside is the most delicate aerodynamic region. Even minor contact can disturb airflow beneath the floor, reducing downforce and destabilizing the chassis. Hamilton continued driving without realizing that the car may have suffered aerodynamic disturbance. This small detail, revealed during Ferrari's internal review, formed a critical part of the explanation behind the erratic behavior he experienced for the rest of the session. His difficulties were not only thermal, they were structural. The lack of tire temperature then combined with the possible disruption beneath the floor to create a car that was nearly impossible to control. Hamilton reported unpredictable movement through slow and medium-speed corners, describing moments where the front glided across the surface before the rear snapped abruptly. Ferrari's engineers saw this same inconsistency reflected in the data. The tire temperature curves were far below the ideal range, and the aerodynamic load values were inconsistent in ways that matched Hamilton's feedback. The SF25 was oscillating between different states of balance within a single lap, forcing Hamilton to react constantly rather than drive proactively. Leclerc, despite managing a stronger lap, left the session equally angered. His complaints echoed Hamilton's almost word for word. The tires did not fire. The balance was unstable. The car responded as though the surface were too cold to support its aerodynamic concept. Ferrari faced a qualifying session where both drivers reached the same conclusion independently. The SF25 was incapable of performing in conditions that required rapid tire heating and stable downforce generation. The combined frustration of Hamilton and Leclerc did not come from emotion. It came from recognizing that the car had failed them at a fundamental engineering level. Ferrari's engineering team began their post-qualifying investigation by analyzing the tire temperature curves, and what they found explained the core of Hamilton's collapse. The SF25 was never able to move the intermediate tires into the correct operating range. Instead of building heat, the tires cooled progressively with every corner, and the telemetry made this failure impossible to ignore. In conditions where temperature determines grip, the car delivered numbers that were consistently below the threshold required for predictable behavior. The engineers saw the same pattern on Leclerc's car as well, confirming that this was not driver-specific. It was a structural deficiency that both drivers had been warning about for months. With the thermal issue established, Ferrari turned to the aerodynamic load data, and the findings were equally alarming. The SF25 relies heavily on ground effect to generate stability, but the wet Las Vegas surface interrupted the airflow beneath the floor. Water flowing into the tunnels distorted the pressure distribution, weakening the suction effect the car depended on. For Hamilton, this was compounded by his earlier contact with a displaced cone. Even a minor impact beneath the car can disrupt the delicate airflow channels, and once the engineers inspected the underside, they found evidence of contact exactly where such a disturbance would be most damaging. This provided a critical explanation for the erratic balance Hamilton had reported throughout the session. Ferrari then cross-referenced this aerodynamic disturbance with the tire behavior, and the interaction between the two systems made the problem far worse. When the tires cool, the car rises slightly, reducing the sealing effect of the floor. This loss in sealing breaks the pressure stability beneath the chassis, weakening downforce even further. The engineers saw sudden dips in load values during Hamilton's lap, aligned perfectly with moments where the tires were at their coldest. The SF25 was failing at both the mechanical and aerodynamic levels, leaving Hamilton with a machine that could not generate grip, could not retain energy, and could not stabilize itself even with perfect driving input. Leclerc's data confirmed the same pattern, though his lap was executed with slightly better rhythm. His car also suffered from persistent under-rotation and late corner instability, both symptoms of tires refusing to enter the correct thermal window. Despite avoiding the cone incident, Leclerc still reported balance shifts that matched the fluctuations in downforce shown in telemetry. Ferrari realized quickly that this was not a situational failure, but an inherent weakness in the SF25 that had been exposed brutally by the cold Las Vegas night. Both cars behaved identically in their thermal and aerodynamic collapse. Hamilton simply experienced an additional blow in the form of the floor disturbance.